I'm Anil Kumar, and here is a question from the book 3.1 Exploring Polynomial Functions. Sketch the graph of a polynomial function that satisfies following set of conditions. F of minus 3 equals to 16, f of 3 equals to 0, f of minus 1 equals to 0, y-intercept is 2, f of x is greater than or equal to 0 when x is less than 3, f of x is less than or equal to 0 when x is greater than 3. So let us try to sketch this function, right? So all my sketches are based on very rough diagrams, right? But they are kind of accurate. So I'll show you how to sketch such a graph. When we say f of minus 3 is 16, that means that at minus 3, the value of the function is 16, which is kind of high value. So what I will do is, I'll just put a point at minus 3 somewhere here, right? Now, that just gives me an idea that we have to cross this point, and it should be included in our graph. F of 3 is 0 means that at x equals to 3, we have a 0. So at 3, we have a 0, so that is the point, 0. F of minus 1 is a 0, means we have a 0 at minus 1. Now y-intercept is at 2, so somewhere here we have a y-intercept, let's say that is at 2, y-intercept. Now we have f of x is greater than or equal to 0, that means the function is positive when x is less than 3. I should say the function is non-negative since it is script. When x is less than, so when you are on this side of 3, the function is kind of here, right? So it's positive or non-negative, right? So that shows that the end behavior is when you are approaching negative infinity, y value should be positive. When f of x is okay, then we have f of x is negative, that means less than or equal to 0, it could be 0 or negative. When x is greater than 3, that means kind of in this region, right? Now, knowing this, we have to connect a graph. That is so simple. So we have to just connect these points, but take in consideration that for a function which is a polynomial function, your graph should be very smooth, right? So what we will do is we have to bounce back here since we cannot go to the negative side, and then we have to somehow cross this line and then come down here, right? So what we will do is we'll try to connect these points with a smooth graph like this. Do you see that? And then we'll just go up here and then go kind of like this. Do you see? So this point is at minus 3, and the value for us, we can think that we have a break here. This is 16 for us, right? And here we have a function which has a 0 at minus 1 and a 0 at 3. So that graph actually satisfies the given condition. Y-intercept at 2, this is good to mark this point, at 2. F of x is greater than or equal to 0 when you are on left side of 3. Do you see that? And if you're on the right side, it is less than 0, right? So it's an odd function with zeros at minus 1 and 3. I hope that helps, right? But remember one thing, for such conditions, you could have a variety of graphs, right? So you could draw a graph like this also, right? It is not necessary that your graph, your graph could be anything kind of like this also, right? So there are many possibilities, remember that. You could have got a unique graph only if we assign some other points, right? Which we do have. At times, with given conditions, you may have to find equation of a graph. If that is the question, you should say f of x should be a times one possible equation. 0 at 3 means x minus 3. At 1 means x plus 1. And since at minus 1, you have to bounce back, this 0 is of multiplicity 2, and then you can find the value of a knowing this point, that is f of minus 3 is equal to 16, right? So if you put minus 3 here, minus 3 minus 3, minus 3 plus 1 whole square, you get minus 3 minus 3 is minus 6, and minus 3 plus 2 is minus 2 square is 4, correct? And from here you get the value of a as equals to 16 divided by negative 24. Let me write negative 6 times 4, simpler, since we can simplify this equation, right? So you get 4 times, and then you can simplify this 2 and 3, right? So a is minus 2 over 3. So since the point is given to us, we could actually draw very accurately. And now let's look at the function again. F of x is minus 2 over 3 x minus 3 times x plus 1 whole square. So some of you who will derive the equation, which is this equation for the given function, can on the graph paper draw very accurately. So I'm not sure whether how high it goes, right? So what you can do is you can make a table of values and find the values for, let us say, f of 1 and f of 2, right? Even, but this side is not so critical since it is just going very high, right? This side is indeed very critical, especially these two values and f of 4. I think if you calculate these values on the graph paper, you could actually graph very accurately. So depending on marks for the question, if this question is, let us say, 2 to 3 marks, then what I did is perfectly fine. But if it is 5 plus, then you probably need a very accurate graph. Keep that in mind. From these given conditions, we can actually find the equation and make a very accurate graph of a polynomial function. I hope you appreciate it. Thank you and all the best.